All right, welcome everybody to another live stream. This is week 6 for my open Q&A, and I look very excited to go live with you guys and answer the questions that you guys submitted on the live chat. If this is your first live stream with myself, basically what I'm going to do is just kind of cover some questions that students have submitted, and if you'd like to have your questions submitted, then please feel free just to make sure that you join in on the community post. I'm not going to go back to the community post for now, but I will. I do go live every Sunday night at 9 p.m. Eastern Standard Time. I am going to handle, I think like around six or seven questions at least that are or have been pre-submitted. And then obviously if I have a little time at the end, I try to keep my streams roughly between like 30 and 40 minutes. And if I'm able to answer some questions, then I will be happy to go ahead and get those questions in there. So please feel free, if you do have a question, put it into the chat. If I'm not able to get to it tonight, then hopefully some people in the chat will be able to help you out. So far, we've had some really great conversations going on where people have been helping each other out, at least being, giving them a direction on where to go. And I really do appreciate those of you that are helping each other out, because obviously, most of us are here for the same reason, is either to help, to give help, or to help others with their math. And, I'm not able to obviously answer every question that's either submitted or, that has been provided to me. But I do see that you guys have joined on. Good to see you guys. So let's go ahead and let me see. Where's my checked in there? All right, well, let's go ahead and get started here. And then what I'll do is I will go ahead and get started with the problems, and then I'll go ahead and get into the chat and say hello to all of you guys, or then if you guys have any more additional questions. So let's go ahead and get right into this one. So what we're going to cover in this stream here, we're going to solve an absolute value equation. We're going to find the domain for an absolute value equation. We're going to solve a proportion. Let's see, we're going to evaluate the limit. Typically, I don't get too much into calculus from this, but this is something that we actually covered this year for our pre-calculus. So we will touch on limits. So therefore, it's something I cover a lot. The reason why I don't cover a lot of calculus is just because I'm not doing it day to day. So my explanations are not like as on point as I would kind of like for them to be. So hopefully my goal is to kind of be back into the calculus realm so I can kind of brush up on some of my explanations. But either way, we'll cover this problem for limits of a piecewise function. Then we're going to apply a limit at infinity of this rational expression. Then we're going to do a trigonometric equation. I typically don't do word problems, but this one was fairly basic, where they had an angle of elevation and an angle of depression, and they just needed to find h. So I kind of bent a little bit and just kind of drew a picture to cover that. Then actually we have 8 questions. And then we'll do a systems of equations. They said they didn't ask me how to solve, so I'm just going to pick the method that I want to choose. And then question number 8 is apply the transformations to write a function from there. So I know there's a lot of you guys that also submitted some other questions that I was either able to get to or at least respond to you from on there. But just a reminder, guys, if you do have some questions for your classes, when you do submit them, try to be as specific as possible so I can have an understanding of exactly what it is you're asking or what you would like for me to do on the live stream. And obviously, if it's something that I can respond to on the chat, I will. Not always am I always going to do everything on the open chat or in the live stream. And then some things I just, I'll just tell you either I don't understand what you're asking, or it's just not something my explanation I'd be able to cover, from on there. So otherwise, so you guys have all joined in. So let's go ahead and actually get started again. All right. So the first one, when solving an absolute value equation, we know we have those like 2 cases, but the first thing is, before we go ahead and get to the 2 cases, we want to make sure that we understand why we have, how do we get to that 2 cases? So the first thing we're going to want to do here is we're going to want to isolate the absolute value. So whenever you're solving an absolute value equation, we want to isolate the absolute value function. I'll kind of further explain this in a second. So we're going to treat this kind of like a variable, like 5x minus 7 equals 38. Okay, so we're going to isolate this x. So just like we would do with an x, we're going to isolate the absolute value. So therefore, I'm going to add a 7 to both sides. And then I have 5 times the absolute value of 9 minus 5n equals 45. Then I'll go ahead and divide by 5 And you can see here that I have 9 minus, oops, what happened here? 9 minus 5n is equal to 9. Okay, so now I have the absolute value is equal to 9. Now we need to understand our two cases, okay? So remember, if I had like the absolute value of x is equal to, let's just say 2, well, there's really two cases, right? We could say x is equal to 2, or we could say negative x is equal to 2, right? There's two possibilities because if you had x equals 2, then obviously the absolute value of 2 is 2. Or if x equals, I'm sorry, I wrote that wrong. I thought I said it right. Or if x equals negative 2. If x equals negative 2, well, the absolute value of negative 2 is also 2. So we have these two cases. So when we're solving absolute value equations, the first thing we want to do is make sure you isolate the absolute value. And then what we're going to want to do is now apply the two cases. So we can drop the absolute value symbols here. Now it just creates the positive case as well as the negative case. Okay, so now we're just going to solve for n. So we have these two cases, just like we did over here. This one, I didn't really have any math, but here we're going to subtract a 9. And then we get a negative 5n is equal to 0. Well, obviously you could divide by negative 5 here, and we get n is equal to 0. In this case, we're going to subtract 9, and now we're going to have a negative 5n equals a negative 18. Divide by negative 5, divide by negative 5. Negative 5 does not divide evenly into 18, so I'm just going to leave that as an 8n equals an 18 over 5. And again, you can always plug these back in to make sure that they work. And again, we can plug 0 back in for 5, and you can see that's going to be 0. Absolute value of 9 is 9. We can plug in 18 over 5 in there. That's going to, the 5s will divide out. That becomes a negative 18. 9 minus 18 is going to be negative 9. Absolute value of negative 9 is 9. So therefore, they both work. And I believe I did see, I thought I sent these. I thought I saw a super chat from Cases. So yeah. Okay, Pasa, thank you so much for the super chat. I really do appreciate that. And I'm not sure if you, I didn't see a question if you do, but if you did have a question, I'll make sure I get to it by the stream because I do appreciate you providing the super chat here. So, all right, so for the next question, we have f of x equals x divided by x minus 8. Find the domain. All right, so when we're looking into identifying the domain, basically what we're doing is we're looking for the values that are not going to be defined for the function. And, you know, to kind of keep things simple for here, obviously there are other functions when, you know, our domain is going to be not defined. In this case, we have a rational function. And typically, when we have a rational function, we have a polynomial. What we're looking for, a polynomial in the numerator as well as in the denominator, we are looking for when is the denominator going to be 0, because that is going to make our function undefined. All right. So you can obviously, you can probably see that. Well, when x is equal to 8, the function is undefined, right? So you could just say like x cannot equal 8, because when x equals 8, that makes my denominator equal 0, and we can't divide by 0, right? That's not going to be defined. So how do we rewrite the domain? Well, basically, for a function here, we know that, if we were just going to have this polynomial function, it's going to be defined for all real numbers. But it's going to basically now, we're going to say all real numbers except number 8, right? So the domain is all real numbers except 8, right? Or when x equals 8. So a couple ways that we kind of work on this is we kind of draw a number line, right? And we can say, okay, here's 8. So basically every other number on this number line, here's like all the set of all of x values. This is a set of all x values. All these values are defined except for 8. So you can see everything to the left of 8, everything to the right of 8, right? So therefore, to write this in interval notation, which is the notation that we use in our pre-calculus class, I can say, well, if I keep on going to the left, smaller and smaller numbers, that's going to be to negative infinity. And that's going to go all the way over to 8, but I'm going to use a parenthesis because 8 is not defined. And then we're going to continue from 8 being not defined all the way to infinity. And we'll just go and connect those with the union symbol. All right, then. All right, for the next one, I believe this is what the student was asking. They didn't provide parentheses, so based on their comments, they were talking about dividing by k minus 2 instead of just dividing by k, because that would have made the problem a little bit not as nice. So one of the things is, we need to understand, like, when we're trying to solve an equation, for instance, if I had x over 3 equals, let's just say, I don't know, 1/2. If I wanted to solve for this, all I need to do is I need to undo what's happening to my x. Well, you can see my x is being divided by 3. So I'm going to undo divided by 3 by multiplying by 3, right? So therefore my answer is 3/2. Now, if I just flip this around a little bit, if I said now this is 3 over x equals 1/2, well, now I can't just like undo, like I'm going to still apply that same operation, but you got to understand, like, we can't solve for x when it's in the denominator, right? We got to get x off the denominator. So when I multiply by x on both sides, just like I would have done in the other problem, what I obtain now is 3 is equal to, 1/2 x, which is x over 2. Now I can multiply by 2 on both sides to undo that. So you can see how it's kind of like that. It's like an extra step that we have here. But again, the goal is to get rid of our denominators. So in this case, I would need to get rid of k minus 2. So that's why your friend, or I can't remember who it was, multiplied by k minus 2. If you just multiplied by k, that wouldn't do anything. Like, you would have to, like, that would not divide out with the k minus 2 in any case. So therefore, our goal is to have that denominator divide out. So therefore, just like the x's divide out here or the 2's divide out here, I need to multiply by a k minus 2 on the right side as well as on the left side. Okay. Now, it's very important for us to understand here on the right side, they're going to divide out just like the x's divide out here. So I'm only going to be left with a 10. On this left side, I could distribute the 5, but I'm just going to leave that as is. And I'm just going to write it like this. 5 times k minus 2 all over 9 equals 10. The reason why I'm just going to multiply this out, just because I want, for a little simplicity purposes, we need to solve for k, right? So you could multiply by, like, if you distribute that, then you're just going to have to undo that at the end. So the way that I look at this is you could multiply by 9 on both sides just to get the 9 off the denominator, right? Like we did over here. But then you're going to have to divide by 5. So what we could do is just multiply by the reciprocal, right? If you're multiplying by 5 divided by 9, if you want to undo that, then you just multiply by 9 and divide by 5, right? It's basically multiplying by the reciprocal. 9/5 and 5/9 are reciprocals of each other. So now you're just going to be left with k minus 2. And then here, you can say 10 over 5 goes to 2, so that equals 18. And then you can add a 2 to the other side. So k is going to equal 20. All right, question number 4, the limit. So in this case, we have a piecewise function. I would recommend it kind of be helpful to know, the general idea of what's happening with this graph or what it's going to kind of look like. And therefore, then we can kind of go from there. So let's just kind of graph this. Let's graph these two functions, how they would look. So we have 1 equals 4x. Well, again, that has a y-intercept of 0, right? So 1, 2, 3, 4, and then over 1. So that graph kind of looks something like that. And then the other graph is the reciprocal function. Well, again, that has a coordinate point of 1, 1 and negative 1, 1. So that graph looks something like that. They don't look a lot like that. However, this is not at 1. This is supposed to actually be at 1/2, right? So it actually looks like, yeah, it's actually not too bad. I'm not really that far off, actually. So at, that's kind of silly. It's the same point. That's less than equal. That's 1 and greater than equal. I wonder why you would do it for that, but interesting question. Let's go ahead and, yeah, we can use this. So that's what the two graphs would look like on the same, but obviously that's not a function, right? So we need to understand, what this graph looks like from one to the other. Well, how am I gonna, what's the best way to kind of explain this? Okay, so this is, all right, those are the two graphs on there. But let's kind of get back into what we have here. Here, let me do this. Okay, so I have the two graphs, but again, that's not a function, right? It doesn't pass the vertical line test. You can see they have same points. So rather than graphing 4x for the whole domain, we're going to restrict the domain, right? Kind of like in that problem for the domain restrictions. Now, this is defined for all x values, but now I have a domain restriction for x values only greater than or equal to 1/2. And actually, yeah, let's just use a different color. So now for greater than or equal to 1/2, if I were to plug in 1/2 here, right? If I was going to do 4 equals 1/2, that would equal 2. So this is graded for all values greater than or equal to 1/2. So that graph is going to look like, so if I plugged in 1/2 here, that'd give me 2, right? So you could say, so then at 1/2, right? Because that's half of 1, I'd be up to 2, and then I just continue that graph. That means the rest of the red graph is actually not part of the piecewise function. So I'm just going to erase it from there. Then the other one is the reciprocal function. Now the reciprocal function is for all x values greater than 1/2. Less than 1/2. So, okay, that's going to be values less than 1/2. Well, you can see that, and when x is equal to 1/2, you can see that actually it's equal to 2 here. Again, kind of odd, right? So when you have 1 divided by 1/2, that's also going to equal 2. But again, remember that's undefined here. So that value is actually going to look kind of like that. It's kind of weird in this problem. So I'm kind of getting a little bit more, I'm trying to focus on the graphical approach, and this problem is really not helping with the graphical approach, basically how it's looking, because they both meet at this point. But basically the way to do a problem like this, I'll just kind of get to the point here now because the graphing is really not helping out my explanation. So basically what you want to do is, the limit is saying what is the value of f of x as x is approaching 1/2. Okay, so it kind of looks a little odd here because, or let's delete this here, because we want to see as the graph is approaching 1/2 from the left as well as from the right. Okay, now you can see though, actually, never mind, that actually works here. So we can see that at 1/2, so when I plug in 1/2 into both these equations, you can see that they both equal the value of 2, right? Now this function is actually defined at 1/2, where this one is not defined at 1/2, but it doesn't matter. It's kind of like having, so let me actually kind of draw a little bit bigger like here. So here's 1, here's like 1/2, here's 1, 2. So we have this open circle, right? Because that's what that graph, there's the reciprocal function. And then what we have over here is this graph kind of looking like this. So this graph, this is the reciprocal port function. It's only for x values that are less than 1/2, right? So that's going to be going to the left. Sorry. Okay, because this is important to kind of understand, and I'm glad actually I went back through it. And then the vertical function actually starts, it fills in, right? Because it goes from here, it fills in, and then it goes up from there. But we don't need to include anything to the left because it said for only x values greater than or equal to. So here's kind of like a zoomed in approach of what I was trying to show. The important thing is the general limit only exists is when the function is approaching the same y value from the left and from the right. So even though this value is undefined at 1/2, you can see that it is approaching the y value of 2. Whereas also when you plug in 1/2, it's approaching the y 1/2 into the other function. You can see it's also approaching 1/2. So therefore the limit as x approaches 1/2 of the function f of x is equal to 1/2. So basically what we want to do is we want to plug in that value. We want to do direct substitution into both of those functions to make sure that they are approaching the same value. If they are not approaching the same value, then the limit would not exist. Okay, but again, the limit is not looking for the value of the function. We're looking for where the graph is approaching. And for the general limit, it needs for both of those, or needs to approach that value from the left and from the right. Okay, you can see obviously it's been a while from the limit, so my explanation was not as on point, but that's why I don't cover as much calculus, just because we haven't gotten to it and it's been a while. All right, so then I decided to do another one. Now in this case, there's a couple different ways we could obviously go ahead and look into this as far as identifying, the limit as n is approaching infinity. And And so basically what we're looking at is, so the limit as n is getting bigger and bigger and bigger, right? So as we're going to keep on plugging in larger and larger and larger numbers into this function, like where is it going to be like approaching, like where's it going? So I'm not going to go through the calculus version of this. What I'm going to do is just kind of go through like the pre-calculus way, or just kind of a simplified version, not really getting into depth on this. But the main thing I want to look at is this is again a rational function. Now we talked about undefined values here. Okay, so if we look at this, like this was an undefined value. This was a, this is a in the rational function, and you can see based on this undefined value, that is creating a vertical asymptote at x equals 8. It's undefined. It's actually an asymptote. It's where the graph approaches from the left and from the right. It's not a hole because the x's do not divide out. It's not a removable discontinuity. Whereas over here, same thing, we could find the vertical asymptotes if we needed to. If we needed to solve for the discontinuities, that's not what the question is, but we could do the exact same thing. We would set the denominator equal to 0 and solve to be able to identify the domain of this function. But when we're doing rational functions, one thing that we worked on is finding the vertical asymptotes as well as the horizontal asymptotes. And so that's one thing that's going to help us here as n is going to be approaching infinity, is we're going to be looking at as we're approaching infinity and negative infinity, doesn't really matter each one, like it's going to be approaching the horizontal asymptote. So if we do have a horizontal asymptote, we know the graph is going to be approaching that asymptote as it continues to expand. So in this case, you can see, if you remember from our rational functions unit, that this has a horizontal asymptote. So the horizontal asymptote, in this case, since the degree in the numerator is equal to the degree in the denominator, the horizontal asymptote is going to be y equals 4/3. So that's going to be the value that the graph is going to approach. Okay, so without getting into, again, as I mentioned, a little bit more deeper stuff that we do in the calculus form, we can say that the limit that this graph is going to approach, because again, remember that's the definition of an asymptote, is the value that the graph is approaching. As this graph is approaching infinity, for this case, we know that it's going to be approaching our horizontal asymptote, which has a value of the leading coefficient over the leading coefficient because the degrees are the same, which is 4/3. And I do see that I had another super chat come through. Thank you so much, guys. It's so nice of you. But now I didn't get to him in time. I didn't see it, so I apologize for that. And I will make sure if I, oh, he had that. Okay. Okay, Basa, thank you. You are very welcome. I'm very happy to be able to help you out. Sorry, I just had to kind of go back and go to them. I could have swore. Uh-oh. Oh, my chat's, the streams. I don't know. All right, well, it looks like everything else is still going fine. I don't know. I got a warning on the stream health, but it looks like everything's good. So I'm just going to continue on. But I thought I did see another Snapchat or super chat. But anyways, I'll make sure I go back through the chat, and at least I'll reach out to you if anything, if I don't get back to it. So again, thank you so much. It looks like my chat was connected back again. Not sure what was going on. All right, so let's go ahead and get into this problem. So this was, again, for my word problem, which I typically don't do. So please save yourself the time in typing out a word problem when you're investing in this community chat. I just don't have time, and nor does really anybody want to read through a word problem. I know that's definitely a lot what you guys want to do, cover, because they are problems that are difficult, which I do have a great new video being released, I believe this week, all on word problems. I think I'm going to do 26 word problems. So at least, I'm sorry, I'm not going to do 26 problems. I'm going to set up at least the picture of 26 word problems. But I do have some classroom videos on word problems that I'll be releasing in the next week or two. But anyways, so let's go and get through this triangle. And so again, I had an angle of elevation of 8 degrees. We had an angle of depression of 11 degrees. And just remember, the angle of elevation and angle of depression is from a horizontal. Okay, so if you have a horizontal, in this case, the angle of elevation was the horizontal above the ground, right? So therefore, that's why it is an angle of elevation. Whereas an angle of depression, I can't remember what the angle of depression was, or or what it was from, but it's always going to be from a horizontal. I don't remember that. I can't remember if it was like a line or a pathway or something like that. But just remember the angles of elevation, the difference between them. So it's always going to be from a horizontal. Elevation's up, depression is down. Now you could go ahead and figure out the rest of this angle if you wanted to. You don't really need to in this case because you already have all the information that you need. But just remember, if you have a 90-degree angle, and this is 8 degrees, the triangle's not really drawn well, you can use the interior angle sum theorem, right? That all the angles in a triangle add up to 90 degrees. Or you could also recognize that this angle is complementary as well, right? So therefore, this angle is going to be 170, which that doesn't make any sense. You know, that's why I not do word problems, because if that's complementary, oh, yeah, that doesn't make any sense. Yeah, that problem, you know what? I'm not covering that problem. That's why I'm not doing word problems. Oh, that doesn't make any sense. And I'll just explain why it doesn't make any sense, actually, and not erase it. Why should I erase it? Based on the problem that I was at least provided, which I kind of went out of my element and say, all right, I'll do a word problem. But again, guys, if you have an angle of elevation of 11 degrees, that means this angle, these are complementary, right? This angle plus this angle is going to add up to 90 degrees. So therefore, that means this angle is 79 degrees. But that doesn't work, because if you do 8 degrees plus 79 degrees, that's going to be 86 degrees. And 86 degrees plus 90 degrees does not add up to 180. So there's something going on here. It's either I misread the problem or the student did not type in all of the information correctly. So I'm not really sure what that is the case. Let's just pretend, for the sake of at least doing a math problem, that 11 degrees was incorrect. And therefore we just have 8 degrees. Like, what would we do here? Okay. Well, again, if we have a triangle, a right triangle to be that, and we have an angle and we have two side lengths, we just need to say which trigonometric function does that represent. In this case, we could say the tangent of 8 degrees is equal to opposite over adjacent. And now to solve for h, we're just going to, kind of like what we did before, we're just going to multiply by 10. So we have h equals 10 times the tangent of 8 degrees. I'm going to leave it there because I typically, I'm not going to have a calculator with me from the live stream. So then you just type it in. Just make sure on your calculator that your calculator is set to degree mode. All right, last two questions, guys, and then I'll get into the chat and hopefully maybe get into some questions. Yeah, we'll see how much time we have. But at least check in with you guys. So, all right, so we have solve y equals 4, y equals 4x minus 1, and y equals 8 plus x. So in this case, we could solve by graphing, we could solve by elimination, or we could solve by substitution. Now, typically, graphing is only really going to be one used unless you need to use graphing. Typically, algebraically is going to be your two best methods. And preferably like to use substitution whenever we have a coefficient of 1 for our x and our y variables. Or, obviously, one of our variables is solved. And in this case, we have y is solved for both these equations, right? So, again, if y equals 4x minus 1 and y equals x plus 8, well, then therefore 4x minus 1 has to equal x plus 8, right? That's like me saying y equals 10 and y equals 9 plus 1, right? So if y equals this and y equals that, well, obviously we know, like, that's obvious. 10 equals 9 plus 1, like it's the same thing, right? Now, in this case, we don't know what x is, and that's what we're solving for. We're trying to find the value of x. But if we know y is equal to this and y is equal to that, then those two also have to be equal to each other. So now we seem to get the x to the same side. So I'm going to subtract an x on both sides. I get 3x minus 1 equals 8. Then I'll add a 1. 3x equals 9, divide by 3 on both sides, x is equal to 3. But again, that's not the whole story, right? Because you can see we have two variables. And when we're solving a systems of equations, basically we're solving an equation where we have two variables. We need to solve for x and solve for y. We need to find the solution that makes both of those variables true, or when they're both, or we need to find the solution when they're both true. So now what I'm going to do is just plug 3 into one of these equations. It looks like this one's a little bit easier than the other one. So I'm going to just use parentheses here so you can see that I'm inserting them. I don't know why I'll do that. And therefore you can see that y is equal to 11, right? 3 plus 8 is 11. Since we're using x and y's, if we were to graph them, we would see that these two graphs cross or intersect at the coordinate point x comma y, and that would be your solution point. All right, last question, or at least that's been preset here, but I will try to see if there's any questions you guys have in for the chat, especially since I appreciate you guys staying on with me up to the end. So the last one is apply the transformations. F of x equals the square root of x. Basically, the student was asking, like, how do I apply transformations to get a new equation? So the transformation the student gave me, which I abbreviated, was the vertical stretch of a factor of 2, a horizontal shift left 3, and a vertical shift down 4. So it doesn't matter if you had, like, what I usually recommend with students is just do quadratics. Like if you had a times x minus h squared plus k, like, let's not use the h and k. But if you remember, like, this is vertex form, x minus c squared plus d, okay? And again, in our chapter with transformations of functions, we do this for all functions. It doesn't matter if it's cubed root, you know, the absolute value, anything else. Like a is your vertical stretch or compression, and actually I should probably do B is your horizontal stretch or compression. C is your vertical shift, and C is your horizontal shift, and D is your vertical shift up or down. So if I have a vertical stretch of 2, then that's going to be my A. So in this case, for my function, which I'm not using f of x, so I should probably use a different function there. Just call it that. All right, so that is just a review. So let me just put that in a box so then people aren't confused. Be like, why are you talking about quadratics? All right, so that's just a quick little review. So I'll just write review. So if we have the square root of x, if I wanted to write that in transformation form, or with all transformations, I would have a times the square root of b times x minus c plus d. So again, the main thing is notice that a and d are outside of the function, b and c are inside the function. When you have transformations outside the function, that's vertical. Transformations inside the function are horizontal. So if I have a vertical stretch of 2, that's going to be my a. So I'm just going to replace a with 2. If I have a horizontal stretch left 3, that's going to be c. So there's no horizontal stretch or compression, nor a horizontal reflection. So therefore, I'm going to have x plus 3. Right? Because if you're going to the left, that's a negative 3, right? So actually, let's actually write it like this. So that's going to be an x minus a negative 3, because a lot of students get confused with that, right? B is 1 because there's nothing going on horizontally, or no stretch or compressions. And then I have plus d, which is down 4, which is minus 4. So do you see how the 3 and the 4 are both negative? That's telling me it's going to the left as well as going down, right? But one's horizontal, one's vertical. Then I can just simplify this. Don't really need to write the 1 to x plus 3 minus 4. And there you go. That is your equation now with the transformations of provided. So, thank you guys. That's it. So I see it. I'm not sure what extraneous solutions you are referring to, but if you type it once, then I will receive it and I see it. You don't need to go ahead and continue typing those in. But just once is perfectly fine. Thank you so much. Yes, guys, it's all right. I will receive the questions and I will try to get to them as possible, but I do appreciate seeing Mason, Gwenshire, Wendigo still on, Crispy, Patrick. Thank you very much, guys. Jacqueline, Megan, thank you very much. I appreciate it. I really appreciate you guys staying on. And yeah, I'll try to get to some questions that you guys maybe have. Ice is getting into gravity as a constant. Yes, okay, helping some people out. Awesome. All right, so Mason has posted a question more than once, so I'll try to at least get to it. How could you solve a problem like sine of pi over 6 plus tangent squared pi over 6? Well, I'm not sure what your I believe you mean to evaluate because there's no equal sign there, but I'll cover that. But I believe you mean to evaluate. So if I had the sine of pi over 6 plus tangent squared of pi over 3. Okay. And I believe your thing is evaluate. We want to find the value there. All right, so let's see if there's maybe any other questions I can get from you guys. Chrissy says, hi, can you please help me on interior and exterior angles? Because I'm struggling right now. I'm trying to stuff for my math quiz. Yeah, the only problem with the interior exterior angles is I just don't remember all the formulas from geometry. Was it n minus 2? Yeah, I just don't remember the formulas. I know that it's been a while. Let's see. I guess there's one thing that I can at least remember here. Because I think you can pick up like the sum of interior angles is going to always add up to 360, right? So like if here's your angles, I believe it's going to be 360 divided by n, the number of sides, right? Yeah. So that's going to at least be one interior angle is 360 divided by n. This is going to be for a regular gun, meaning the same sides or the sides are all equal. But remember that when you have for each one on a regular gun here, that as you keep on getting larger and larger, we're obviously going to get to a figure that's not going to have any sides, which ends up being a circle. And we talk about a circle, obviously has no sides, but the degree measure here, or the rotation of this line, is going to be 360 degrees. So if I want to find the in one interior angle, which I believe here, or the one interior angle is just going to be 360 divided by n, where that is going to be one interior angle. Now, as far as exterior angles go, the one thing I would just say is, we always want to extend our exterior angles, right? And I don't remember the formula, so I apologize for that. And just remember that for exterior angles here, that these two angles are supplementary, right? They're always going to add up to 180. So if you can figure out maybe what that interior angle is, we don't want to use those tick marks because I don't want those to say they're equal. But we just remember that these are supplementary, right? So therefore, just remember the exterior angle and the interior angle are going to be supplementary here. So just remember extending those sides. Hopefully, it's been a while since I taught geometry, so I'll try to do my best here. Patrick Solomon, please solve tangent of 14 pi over 3. All right, that's simple enough, so I can... Simple enough, not like it's not a very multi-step problem. 14 pi over 3. All right, so I can cover that one. That's kind of similar to the other one from Mason. And then I'm sure I'm probably going to get like a whole bunch more questions. I apologize for that, because I know people always just flood me questions right at the end when I say, hey, I'll answer any questions. Can you do 7th grade math? I can, if you just let me know what you'd like me to cover. Hasanatu asked you, for a problem like 2x, we factor it, meaning it becomes, I'm not sure. Are you responding to me or you have a question? But for a problem like 2x squared minus 4x equals 5, we factor it, meaning it becomes, yeah, you could factor out the 2, completing the square, or you're creating a perfect square trinomial. Yes, I believe you're being all right from on there. All right. You guys are now asking a lot of questions. Where was the other one? Oh, okay. You guys are talking to each other. Okay, that's cool. No, there's another question. Where was that I was looking for? Oh, Angelica says, what are the multiplicities of zeros? The multiplicity of zeros is how often a zero is repeated. Sorry about that. So for instance, if I had like, y equals x squared, right? We know that graph. Well, let's just talk about it here. Like, what is a multiplicity? Multiplicity is just how many times a zero is repeated, right? So I'm not going to get into, like, if I had y equals x squared, we know the graph looks like this, right? Now, if you were to go through the process of finding the zeros, you'd set y equals 0 and you'd solve, right? And you'd say x equals 0. Well, it equals 0, right? But again, it equals 0 twice, right? Because there's two of them, because there's x equals 0 and x equals 0, right? Because x times x. If you apply the zero product property, right, you factor that to x times x, right? So x equals 0 and x equals 0. So it's the same answer, just repeated. So when you have repeated zeros an even amount of time, that is going to be bounce. When you have zeros that repeat an odd number of time, that's going to cross, or it's going to take that same behavior. So just real quick, if I was going to change this to what if I had like x minus 1 squared and x plus positive 1, right, to the first power. So how does this look different? Well, again, this is going to be a cubic, so I don't want to get too much into there. So we know the end behavior. Hopefully you can, if you were to multiply this out, this would be a positive x cubed. So the graph is going to fall left, rise, right. If you were to set these both equal to 0, you'd have, using the zero product property, you'd have x minus 1 quantity squared equals 0, and x plus 1 quantity squared, or not quantity squared, equals 0. So here you can see that my 0 is x equals 1, but again, it's squared, so it has a multiplicity of 2. So at 1, I'm going to bounce just like I did over here. Whereas x equals negative 1, that only happens once. So therefore, it's going to cross. It's going to streak like a line. So obviously, my graph here is not very well graphed, but you can see the graph would look something like that. So the multiplicity is just how the behavior of the zeros is another way to look at it. Basically how that graph goes ahead and repeats, or how that behaves at as it intercepts. All right. I do not have any comments on the Shakira and J-Lo show. I didn't even see the halftime because I was going live. So obviously you're not on my live stream from there, but I didn't even see it. I didn't even go back and check it, see from there. All right. How do you find the zeros of x cubed plus 64? You would need to use the sum of two cubes. I'm not going to do it because it's going to take a little bit more time, but you'd want to do the sum of two cubes, and then you'd have to use the quadratic formula. Two of those zeros are going to be complex. So just to let you kind of give you a little heads up. The Mike and Rich, though, I need help with probability, permutations, combinations for a math quiz. That's the luck. Unfortunately, I'm not going to be able to cover any more really problems than I already got from here. I do have some. I actually really haven't covered permutations and combinations, though, unfortunately. So I wouldn't even be able to do a great explanation for you. But I'm sure there's hopefully some great other tutorials. I think I do have some videos on it, but not a lot. It's not something that I've covered extensively, at least in my classes. Can I help with interest? I can't help with interest anymore, but I do have a lot of other videos on the older stuff that I can, I do have a lot of older videos on compound interest, I'm assuming you're asking, or maybe simple interest. I did cover quite a bit of those in the past. So hopefully that does help. I don't know why my chat keeps on disconnecting, so I do apologize for that, guys. And hopefully my audio is coming in across okay. But what I'm gonna do is I'm just gonna cover this problem, and then I'm gonna cover that one, and then that should get it to me for the end here. Oh yeah, I'm already past my time. All right. So let's go and evaluate. So if you're going to evaluate from here, we need to basically use the unit circle, and we need to understand this form tangent squared. So remember, this is sine of pi over 6 plus the tangent of pi over 3 quantity squared. Okay, so just remember tangent squared of pi over 3 is the tangent of pi over 3 quantity squared. So now I need to evaluate for the sine of pi over 6. Now I've been doing this extensively in my class. So I would expect my students to be able to know that the sine of pi over 6 is going to equal 1/2. I would also expect that my students would be able to understand that the tangent of pi over 3 is going to be the square root of 3. And then remember, that's quantity 3. So therefore, that's going to give me 1/2 plus 3. Now I can rewrite 3 as a fraction, so that'd be 1/2 as 6 divided by 2, right? Because you want to write it with the same denominator. And again, 6 over 2 is the same thing as 3, right? So therefore that equals 7/2, and I'll leave it as a improper fraction. So I'm just kind of working left or from left to right. I apologize for that, but hopefully that helps. And the last one is, again, another evaluating, but this one looks pretty big, right? At least for the pi over 3, that was on the unit circle. This one's on the unit circle as well, but it's larger than a revolution. So what we're going to do is let's subtract a revolution. So a revolution in terms of thirds would be 6 pi over 3. So 14 pi over 3 minus 6 pi over 3. Now again, 6 pi over 3 is going all the way around the unit circle, right? So no matter what my angle is, right? If I go 6 pi over 3, or if I subtract 6 pi over 3, that's going to take me to exactly where I started. So when I subtract 6 pi over 3, that's going to take me to a tangent of, let's see, that's going to be 8 pi over 3. Well, guess what? I can do this again, right? I can subtract another revolution of 6 pi over 3. So that's exactly what I'm going to do. I'm going to do, again, tangent of 8 pi over 3 minus another revolution of 6 pi over 3. When I subtract another revolution of 6 pi over 3, now I'm left with tangent of 2 pi over 3. Now, this one's very interesting because the last problem had tangent of pi over 3, which we said was square root of 3. But it was positive because pi over 3 was in the first quadrant. Well, now 2 pi over 3 is going to have the same reference angle, which is pi over 3, but it's in the second quadrant. Therefore, it's going to be negative. So that's equal to the negative square root of 3. All right, guys, I am over my time, but thank you so much for staying on with me. And again, if you'd like to join me for the next live stream, which I plan to have be at next week, please make sure you guys join in on the chat. I will make a post on Saturday for you guys to start asking your questions. And again, just try to be as specific as possible, and I will try to do my best to respond to you as well as to include your question on the next upcoming live stream. So I hope you guys have a great night, and I will see you next week. Cheers. All right, now I got to remember all my steps to delete my live stream, or not delete my live stream, but there's so many things. All right.